I hope you found these two problems entertaining. They had some extra little specialties. So we're going to factor to get the roots so that we can mark off the number line, determine the intervals, test values to see which intervals make the entire fraction positive or negative, and use that sign chart to get our solution. Well, the numerator is already factored. You could make it 2x minus 5 times 2x minus 5 if you feel like. The denominator is a quadratic, maybe it factors. If not, we can do the quadratic formula. 1 times negative 28, b is negative 3, and I'm sure you know your multiplication tables well enough that this would be a negative 7 and a positive 4. So the denominator factors to x minus 7 times the quantity x plus 4. And that is going to have to come out greater than or equal to 0. And we're going to find the x's that make it happen. Well, the numerator roots are not quite ready yet. I mean, we can just look at the denominator roots and tell what, the denominator factors and tell what the roots are. This one you might have to look a little more closely. 2x minus 5 has got to have to equal 0. So that means that 2x has to equal 5. So x equals 5 halves, or, because we're going to be plotting it on a sort of a number line, x equals 2 1/2. Now the denominator roots, if these are the factors, then the roots have to be x equals 7, x equals negative 4. And we know we're not going to use those in the final answer. We're going to use them to get the answer, but we can't include them in the final answer. So then we just put them on the number line, starting with the lowest one, which would be negative 4, then up to 2 1/2, and finally 7. Okay, because either the negative 4 or the 7 will make the denominator here turn into a 0, and we can't divide by 0, we know we cannot use these in our final answer. So I'll put an open circle here, an open circle here. Okay, the 2 1/2 can be used. If we put 2 1/2 in this fraction, it will make the numerator turn into 0, which will make the whole fraction turn into 0. And that's okay. We want the answers that make the fraction equal 0. So this is going to be a nice big solid dot. The 2 1/2 must be part of our answer. Now we have our intervals. From negative infinity up through but not including negative 4. Don't include negative 4, but do include the 2 1/2. Include the 2 1/2 up to but not including the 7. And then anything bigger, wow, sorry, that's a positive 7. Anything bigger than positive 7. So it's 3 roots, 4 intervals. We're going to test a value from each interval. From negative infinity up to negative 4, I'm going to go with negative 5. So if we put a negative 5 in here, that's a negative 10, minus 5 is negative 15, doesn't matter because we're squaring it. The numerator's going to always be positive unless we plugged in the 2 1/2. But the negative 5 in here makes this parentheses negative, and it makes that parentheses negative. So our numerator is going to have a positive value. Our denominator is going to have a positive value. Overall, the whole fraction is going to turn out positive if we pick any number in this region. Now we need to pick a number between a negative 4 and a positive 2.5. I'm going to pick 0. 0 in here means negative 5, but squared is going to be positive. 0 in here, this is going to be negative, this is going to be positive. So we're going to have a positive numerator over a negative denominator. Overall, that's a negative result. No matter what x value we pick in this interval, the fraction will come out negative. Got a little carried away with that negative sign there. Something between 2.5 and 7. I'm going to test 6. So 6 in here is going to make the parentheses come out positive. We squared, it's still positive. 6 in here is going to be negative. 6 in here is going to be positive. So we have a positive numerator over a negative denominator. Overall, negative. The fraction will have a negative value for any x we pick in this space. Finally, greater than 7. I'm going to test 8. Not to originally know. So 8 in here is going to make the numerator positive. It's going to make this parentheses positive and that parentheses positive. So we have positives all over the place. Conclusion, positive fraction from beyond 7 on up. All right, so we have our sign chart right here. It's our sign chart. For the solution, we're going to look back to the original. We want to know when is this fraction greater than or equal to 0. So we want any place where the fraction came out positive and any place where the fraction came out exactly to 0. So interval notation always starts with the lowest. We'll include this interval here from negative infinity up to but not including negative 4. United with, we have to include the 2.5 because we need the answers that will make the fraction equal 0. And 2.5 does. We found out on one of the sample problems that we can do this by saying the interval from 2.5 to 2.5 inclusive. United with this part right here, any number in this interval will make the fraction positive, which makes it greater than 0. Any x value from any one of these intervals will make this fraction greater than or equal to 0. So we've got the solution. The next problem was a little strange. It didn't start off looking that way, but it kind of ended up that way. So you know how to factor the numerator. We have the difference of two perfect squares. It's going to be x squared minus 9 times the quantity x squared plus 9. The denominator does not factor, although some textbooks treat this also as the difference of two perfect squares and write it as x plus the square root of 2 times the quantity x minus the square root of 2. Now if you like that, go with it. If that makes you uncomfortable, we'll also do it another way. But everybody should notice that the x squared minus 9 is definitely the difference of two perfect squares. So we can factor that to x plus 3 times the quantity x minus 3. We still have the x squared plus 9, which does not factor. And if you like, I'll put this back to x squared minus 2 on the bottom. Well, we can tell that the numerator roots we're going to have x equals negative 3. And if x minus 3 is a fraction, we're going to have x equals positive 3. We're going to have to figure out something to do with this x squared plus 9. We can actually find out how to make it equal 0 by setting it equal to 0, which implies that x squared equals negative 9. And when we take the square root of both sides, we get that x equals plus or minus 3i. Those are imaginary. We are going to forget the imaginary roots. Those roots that have the I in them, we are not going to include them in our answer. There is no place for them on the number line. We're just going to forget those two roots. But we'll leave the x squared plus 9 in the function. But it's not going to give us any roots. We'll just use the x equals negative 3, the x equals positive 3. The denominator roots, we could go with negative square root of 2 and positive square root of 2. But if you didn't like that, we could find out what the zeros are by setting x squared minus 2 equal to 0. So that would imply that x squared equals 2. When we take the square root of both sides, we're not going to get any i's out of this. We're going to get that x equals plus and minus the square root of 2. So that is going to be a pair of real numbers. But where do we put them on the number line? For that, we're going to need our handy-dandy calculator and ask it what is the square root of 2 as a decimal. It's going to give us an approximate answer. The real roots are square root of 2, negative square root of 2. But that's approximately equal to 1.414, which I'm going to round off to 1.4, negative 1.4, so that we can stick them on the number line somewhere. Right now we've got our roots. We can put them on the number line, starting with the lowest, negative 3, negative 1.4, which is representing negative square root of 2, positive 1.4, which is representing positive square root of 2, and positive 3. And we know that because these will make the denominator turn into a 0, which is a bad thing, we are not going to use those values in our final answer. I'm going to put an empty circle here, empty circle there. Can't use them in the final answer. Now the negative 3 and the 3, we can put those in here. They make the numerator 0, which makes the whole fraction equal 0. Is it okay for the whole fraction to equal 0? We'll go back to where we started. It doesn't say anything about equaling 0. It only wants when the fraction comes out lower than 0. So these cannot be included. We don't want the values to make the fraction equal 0. So none of our roots are going to get to be included in our final answer. But they still help us set up the intervals. Negative 3 to negative 1.4, which is really negative square root of 2. Negative 1.4 to positive 1.4. 1.4 to 3, even though this is really square root of 2. And from 3 out to infinity. Now we get to test values. Okay, we don't have a fully factored form that we're going to test them in, but we're going to test them in here. So we need to pick an x value that is between negative infinity and negative 3. I'm just going to go with negative 4. So negative 4 here makes this a negative. Negative 4 here makes this negative. Negative 4 here, when we square to 16 plus 9, that makes that positive. So we have a negative times a negative times a positive. And then in the denominator, negative 4 here makes this a positive 16 again. Minus 2 makes the denominator a positive. So I have a negative times a negative, which is positive, times another positive. We have a positive numerator, positive denominator. That tells us that this is going to give us a positive answer for the whole fraction. No matter what x value we pick from here out to negative infinity, the fraction is going to come out positive. So now we get to pick something between negative 3 and negative 1.4. I'm going to test negative 2. That's in between negative 3 and negative 1.4. So negative 2 here, that's a positive. Negative 2 here, that's a negative. And a negative 2 in here, when we square it and add 9, is going to come out positive. Negative 2 here, when we square it, it's going to be 4. Minus 2, that's going to come out positive. So we have a positive times a positive is a positive, times a negative is going to make the numerator negative, denominator positive. Overall, the whole fraction is going to come out to be negative in this region right here. Now we have 5 intervals this time because we had 4 roots. So it's a little more work than usual. Got to pick a number between negative 1.4 and positive 1.4. I'm going to test 0. So this one's positive, this one's negative, this one's positive. Down here, if we put a 0, that's going to make the denominator negative. So we have a positive times a positive is positive, times a negative is negative. So the numerator is negative, and the denominator is negative. Overall, that makes a positive fraction. So any x value in here is going to make the whole fraction positive. Whew, 2 left. A number between 1.4 and 3 is going to be, I'm going to pick 2. Positive, negative, positive. Put a 2 down here, that's going to give us 4. That's going to give us a positive. Well, that's going to give us a negative numerator and a positive denominator. So overall, negative result. For this entire interval, any x value is going to make the fraction come out negative. Finally, anything bigger than 3. I'm going to just test 4. Positive, 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 positive. So that implies that any x value in this interval is going to make the whole fraction positive. Sign chart's a little longer this time, but we can use it to conclude where will the fraction be below 0, because that was our initial mission, to find out what x values make this whole fraction go below 0. Well, it's looking like right here. There aren't any places that make it equal to 0, and we don't care if they did. So it looks like it's going to be from negative 3. Now the exact answer would be negative square root of 2. Union this part right here, positive square root of 2 up to 3. The approximate answer would be from negative 3 to negative 1.4, union 1.4 to positive 3. But this is the exact solution. And that will conclude the problems we're going to look at for the lesson 3.2. I hope you'll go to the practice, please, and try those two problems. They aren't quite as tricky as this one. And check your answers. If you have questions, please contact your teacher. Thank you.